to withstand different kinds of loads acting on beams and to maintain the entire beam in the equilibrium condition, various kinds of supports are provided to the beams. Each type of support will provide distinct constraints to the beam. Due to the supports provided to the beam, there will be support reactions. How to calculate support reactions? Let us discuss with the problem. So this is the problem statement. Find the support reactions of the simply supported beam shown in the figure. Here a simply supported beam supported with hinged support at the left end and a roller support in the right end is considered. So on the beam there are 3 point loads are subjected with the magnitudes of 30 kN, 20 kN and 20 kN. A uniformly distributed load of magnitude 10 kN per meter is acting on the beam for the length 3 meter. To find out the support reactions, in the first step we have to draw the free body diagram. Okay. So to draw the free body diagram, we have to convert all the special loading conditions into point loading conditions, and we have to replace the supports by support reactions. Okay. So in the left hand side there is a hinged support. So hinged support will provide constraints to the horizontal movement and the vertical movement. So there will be 2 support reactions, HA and VA. And at the right end of the beam there is a roller support. So roller support will provide it to the beam to constrain the motion along the vertical direction. So there will be a vertical support reaction at point B, that is VB. Here UDL of magnitude 10 kN per meter is acting over the length of 3 meter. So to draw the free body diagram, we have to convert this UDL into equivalent point load. Okay. So here the UDL of magnitude 10 kN per meter is considered, that is per unit length, that is per 1 meter length of the beam the magnitude of the UDL is 10 kN. So here the UDL is acting over the length of 3 meter. So per meter the value is 10 kN. So for 3 meter the value is 30 kN. And the UDL will be concentrated at the center portion on which the UDL is acting. So the equivalent point load for the given UDL is 30 kN and is acting centrally over which actually the UDL is acting. So the free body diagram will be like this. At point A, we have replaced the hinged support by 2 support reactions along horizontal direction HA and along vertical direction, that is VA. At point B, we have replaced the roller support with the support reaction VB. 30 kN, 20 kN and 20 kN forces are already point loads. We have converted the UDL into equivalent point load 30 kN, and that has been located at midpoint of the portion on which UDL is acting. So to calculate the support reactions HA, VA and VB, we can use the equilibrium conditions. Okay, because actually supports are provided to the beams to withstand the loading conditions by keeping the beam in the equilibrium position. The equilibrium conditions are summation of all the horizontal forces acting on the beam should be 0. Summation of all the vertical forces acting on the beam should be equal to 0, and moment of all the forces acting at any point on the beam should be equal to 0. I am going to apply the first equilibrium condition, that is summation of all the horizontal forces should be equal to 0. So the horizontal forces starting from the left support HA, and there is no horizontal loading condition is mentioned in the problem. So HA is equal to 0. Next, apply the second equilibrium condition, that is summation of all the vertical forces is equal to 0. So starting from the left support, VA is acting in the positive y-axis direction. Next, at 3 meter distance from point A, there is a point load that is 30 kilonewton that is acting in the negative y-axis direction. So minus 30 and minus 20, and at a distance of 6.5 meter from point A, there is a point load 30 and 20. Then at the right end of the beam, the vertical reaction that is considered in the positive y-axis direction, VB, is equal to 0. So by resolving this, we can get the expression like this: VA plus VB is 100 kilonewton. So we can keep this as equation 1, because there are two unknowns to be calculated in this equation, VA and VB. So now we can apply the third equilibrium condition, that is summation of moments about any point on the beam is equal to 0. I am going to consider the left point, that is point A. So starting from point B, we can calculate the moments of all the forces about point A. So first I am considering the force acting at point B, that is support reaction BB. So the sign convention for calculating bending moment: for anti-clockwise rotation, the sign for bending moment is positive, and for clockwise rotation of forces about the considered point, the sign for bending moment is minus. About point A, the force, that is support reaction BB, is providing bending moment in the anti-clockwise direction. Okay, so the sign for the anti-clockwise rotation is plus. So plus VB into the perpendicular distance between the force VB and the considered point A is totally 3 plus 2 plus 1.5 plus 1.5 plus 2, that is 10 meter. So next consider this force 20 kilonewton. About point A, this force is causing bending moment in the clockwise direction. So the sign is minus 20 into the distance between this 20 kilonewton and point A is 8 meter, and considering the force 30 kilonewton, about point A, this force is causing bending moment in the clockwise direction. So minus 30 into the distance between the force component 30 kilonewton and point A is 6.5 meter, and considering the force 20 kilonewton, this force is causing clockwise rotation to the bending moment about point A. So minus 20 into the distance is 5 meter, and considering this force, that is 30 kilonewton, about point A, this is causing bending moment in clockwise direction. So minus 30 into the distance between the force 30 kilonewton and point A is 3 meter. So according to the third equilibrium condition, this value should be equal to 0. So here in this equation, the one and only variable is VB. So we can calculate the value of VB as 54.5 kilonewton. As the obtained value of the support reactions with the positive sign, the considered direction of the support reaction is correct, that is in the upward direction. So already we have one equation, that is VA plus VB is 100 kilonewton. So from equation 1, VA plus VB is 100, VB value is 54.5. So the value of VA is 100 minus 54.5, that is 45.5 kilonewton. HA is 0, VA is 45.5 kilonewton in the upward direction, and VB is 54.5 kilonewton in the upward direction.